um, I have used this mouse for about 10 years, and I think it's about time to buy a new one, because when I clicked it once, but it recognizes as a double click. It clicks twice on the unintentionally. I only click once. So what just happened is I clicked I clicked on my computer with this mouse on record, start recording, and then I clicked once, but somehow it clicks twice, and so when I click once, it start recording, and the next click is stop recording. So I just did a lecture without recording. So I'm very, very, very sad. So I have no. I'm not. I'm so tired. Just I had to talk the same thing again. Okay, let's go. So in the previous video, I showed you how to calculate the CDF for the standard normal distribution. So now I'll assume that you can calculate the probability, the cumulative probabilities, and say you get these 5 numbers. Actually, you can try them. Try to find probability at this point, this point, this point, this point, this point. So then, probability smaller than minus 2 is 2.275%. Smaller than 1 is 15.866%. And probability smaller than 0 is 50%. Probability smaller than 1 is this. Probability smaller than 2 is this. So remember, these are cumulative probabilities, and so all of them are defined as the probability that a standard normal is smaller than something, smaller than the given number. Then our natural question is, then how can we calculate probability greater than a number, right? So for example, like this, how can you find probability greater than minus 1 using these information? You do not need Excel, so try to figure this out. So you have 5 information about cumulative probabilities, and from them, can you infer about this probability? I'll try this. So I explained this when I first introduced the CDF in the previous lecture. So try this. Pause the video if you need more time. I will turn the page. The probability greater than 1, like in general, the probability greater than or equal to A equals 100% minus probability smaller than something, right? It's obvious. So random variable is greater than something or smaller than something, so their sum is always 100%. So therefore, if you know one of them, then the other is automatic, right? So if you know this part, this probability smaller than something is the cumulative probability, so you can calculate this from Excel. And then once you know this probability greater than something is calculated this way. So in our example, probability greater than minus 1 is 100% minus probability smaller than minus 1. So probability smaller than minus 1 is given here. So from this number, you can calculate probability greater than something. So I explained, so it's simple. If you think about the area, the total area is 100%, and you divide it by minus 1. Divide it at minus 1. So this side is 15%, and the other side is, the answer is 84.134%. That is the answer. Alternatively, another way to answer that question is this. Probability greater than -1 is this area. -1 is here. So you have to calculate this area. Now you may use the symmetry of the bell curve. If you take the mirror image, then these two are the same area, same shape, right? Symmetric. And this area is probability 1 or below. Probability 1 or below. Therefore, and this probability is a cumulative probability, so you know how to calculate this. We have that here, right? So probability smaller than 1 is 84.134%, which is, again, C. So there are two different ways. Either way, there is no problem, but it's important to understand how you got the answer. And then another important question, another common form of probability is like this. Probability between 2 points. Try this. Try how to calculate this. Given these numbers, you have to use these numbers and try to find this. I'll turn the page. Probability between plus minus 2 can be written this way. So probability in general, probability between A and B can be considered as the probability difference between smaller than B and smaller than A, right? So think about this. Probability smaller than B is area from minus infinity to up to B, and probability, the other probability is probably up to A. So their difference is the difference between A and B, which is the probability between A and B, right? So think about their area. So then the probability between A and B can be calculated as their differences. In our case, plus minus 2, we are considering plus minus 2. So you can calculate probability smaller than 2 minus probability smaller than minus 2, which is 95.450%. So this is a very commonly used numbers, because this is simple number and also this is a commonly used number. Rule of thumb, this is a rule of thumb for the standard normal distribution. Earlier I said standard normal distribution has most of its probability between plus minus and 4, right? But that's not used because the probability, the plus minus 4 is too wide. Usually we consider plus minus 2 as the most commonly occurring range. So 95% of the outcomes lie between plus minus 2. So this interval plus minus 2 is very commonly used later and in this course, later chapters. So you will see this graph again, this image again. Okay, now I will think about another approach. So far, what we considered was when you know A, this number, I taught how to calculate this probability P. But you may go the other way. So now I will think about the problem like, you know the probability P, then how can you obtain A? It's like the relationship between the function. So when CDF is given, if you know this, then you can calculate P, and you can do the other way. If P is input, then you can calculate A, right? It's like inverse function, and this is closely related to the percentile. So if this part is a 90%, If this area is 90%, then A is 90 percentile. If this probability is, say, 50%, then A is median, 50 percentile. If this is 25%, A is 25 percentile or the first quartile. So we learned percentiles in chapter 3, and in the normal distribution, you can understand the percentile as the inverse of CDF. And how can we calculate that? I will consider these 5 percentiles on Excel. So on Excel, I will use another tab, and I will calculate probabilities. So I will consider 5% and 10%. Let me start with 1%, 5%, and 10%, and 50%. So it doesn't matter, 25%, 50%. So like this. And let's go further. 90%, 95%, 99%. These are commonly used numbers. And percentile. Percentile formula is, again, search norm. And then what we are going to use is norm.s.inv. So it is the inverse of standard normal distribution. So click OK. Then there is only one entry, probability. So 1% is, you have to use like a number between 0 and 1, not percentage. So the answer is minus 2.32635. So minus 232. So the probability is smaller than minus 232 is 1%. Or the first, the 1 percentile is minus 2.32. Similarly, you may use the formula directly by typing the formula. So the 5 percentile is minus 1.64485. So small probability smaller than minus 1.64 is 5%. In that way, the probability can be the percentiles can be obtained. I wanted I did it. So sometimes the drag, like the mouse is old, so drag usually does not work, but this time I succeeded. So 10 percentile is minus 1.2. So what you find here is median 50 percentile is 0. So any percentile smaller than 50% should be negative, right? And any percentile greater than 50%, it should be positive. And as you can see, they are clear. And another thing you can find here is minus, for example, minus 10 percentile. I mean 10 percentile and 90 percentile are symmetric. So 10 percentile is minus 1.28 something, then 90 percentile is positive 1.28. So they are symmetric. So bottom 10% and top 10% are symmetric. This is how you calculate percentiles. And the idea is simple. Given the probability, what is this guy? And you could calculate that. And these are simple, like approximated numbers, which we will be using a lot later. So 1.64, 1.28. You will get familiar with these numbers soon. And from this information, try to find the top 10% value. So 5 percentile, 10 percentile, and then I'm wondering what is the top 10% value of the standard normal distribution. Think about this. I will stop the video here and we'll continue in the next one, in the next video. See you later.